Okay, into trigonometry. Let's take a look at the definition of a radian. So if you print off your notes, we can see that the definition of a radian, 1 radian, let's draw a circle. So if I have a circle with a center and an angle theta, where the radius is equal to the arc length, I know that the definition of that theta is equal to 1 radian. 1 radian. Now, what is a radian? Well, a radian measure is a way of measuring angles with something more to do with a circle. For example, we count to 10 because we have 10 fingers only. That's the only reason why 10 seems nice. We count in centimeters because it's easy. 1 centimeter, 2 centimeters, 3 centimeters, 4 centimeters. We don't count in inches because it's difficult. 1/16, 1/8, 3/16, 1/4, 5/16, 3/4, 7/16, etc. So we count in circles with 360 degrees. Now, 360 degrees, what does that have to do with a circle? Well, nothing other than the fact that it has a lot of factors. So we're now going to work in what's called radian measure, which actually has something to do with the circle. So if we take a circle with a radius of 1, I want to find the circumference. So I know the formula, C equals 2 pi r for the formula for circumference. And I know that I have a circumference of 1. I know that's 2 pi times 1, which is a circumference of 2 pi, or 6.28. Now that is the length all the way around the circle, and from now on 360 degrees is equal to 2 pi radians. We don't always write the rad for radians. 360 degrees is equal to 2 pi radians. So now let's take a look at another circle with a radius of 1, but let's only go halfway around the circle. Well, what's the circumference? Well, the old circumference was equal to 2 pi, so we have to divide that by 2, and I've worked it out more thoroughly in the notes. Therefore, the circumference equal to pi, or 3.14. Therefore, I know that pi radians is equal to 180 degrees. And that is the conversion factor that we're going to memorize. In the present, we're going to stick with degrees. However, we're going to start converting to radians and start being more comfortable using radians. Remember, we did a whole chapter last year in trigonometry working with the ASTC realm and different triangles in different locations. We're now going to do all of that same stuff in radians. We have to remember pi is 180. So what would this length be? Well, that's a quarter of way on the circle, so that's a full circle, 2 pi divided by 4, which is a circumference of pi over 2, and we know that is 90 degrees. So we know no matter how big the circle is with any radius we want, that angle is now pi over 2, a 90-degree angle. So again, memorize pi is 180. Rememorize degrees are for children unless you're doing physics. We're going to be using this conversion factor over and over again to convert in degrees, to help us use degrees and allow us to have a more simple transfer from radians to degrees. Keep in mind, we will still be using degrees sometimes, but the majority of the time we'll be doing radians because they actually have something to do with the circle. Okay, let's convert from degrees to radians. So 30 degrees is equal to question mark radians. So I start with what I'm given, 30 degrees, and I multiply by the conversion factor. So remember, pi is equal to 180 degrees. So I have a degrees. I need degrees on the bottom, and I need pi on the top. That has to be my conversion factor. So I can simplify that fraction, and I can cross off the 0 from the top and the bottom, and then I can divide the top and bottom by 3 and get 1 and 6. and 1 times pi is pi, and I have a 6 on the denominator, so I have an angle of pi over 6. We can always check our answer and do 180 divided by 6, substituting 180 in for pi, and that is equal to 30 degrees. So many different ways, but this is the radian measure as the answer for the conversion from 30 degrees. So we can do that again in the notes as I've converted 120 degrees. So let's try that. 120 degrees. Well, we're going to times it by pi over 180. And we're going to simplify as we go. So we can divide the top and bottom by 10, and then we can divide the top and bottom by 6, and we get 2 and 3, and the answer is 2 pi divided by 3. Now that is a radian measure for 120 degrees. Feel free to check your answer by doing 2 times 180 divided by 3, and you will get 120. So let's take something like 99 degrees. Well, that doesn't simplify very much, but I can divide the top and bottom by 9, and I get 11. And if I divide the bottom by 9, I get 20, and I get an angle of 11 pi over 20. Now, no problem if you'd like to convert this into a degree measure. Times 11 times pi divided by 20 equals, and that's 1.72. Or 1.73 for that matter. Feel free to call it radians, but that's implied, and this is a fine answer, and this is a fine answer. And being able to be more comfortable with measures in degrees, measures in radians with fractions, and measures in radians with decimals. As you can see in the notes, we have a big table with a whole bunch of degree and radian calculations and all their simplifications. So what if I want to go back in the other direction? What if I have pi over 3 radians? Now again, remember, we don't need those units. If we don't see degrees, we know it's a radian. Well, I need to multiply by my conversion factor. Well, I know that pi is equal to 180. My conversion factor. This time I have to multiply by the reciprocal, 180 degrees over pi. And what's that equal to? Well, again, I can simplify and divide the top and bottom by pi, and then divide the top and bottom by 3. And on the top we have 6 with the 0 after it, and that is our degree conversion from pi over 3. Notice we did pi over 6 earlier. 180 divided by 6 is 30. Well, now we did pi over 3, and 180 divided by 3 is 60. What if I have something like 2 pi over 5? I'm not even going to say rad this time. If you don't see degree, you know it's a radian. Multiply that by 180 degrees over pi. Cross off the pi's from the top and the bottom. And divide the top and bottom by 5. And we get 1, and 180 divided by 5. 180 divided by 5 will be, 180 divided by 5 will be 40 minus 4 fives, so 36. And if I multiply 2 by 36, I get 72 degrees. Again, feel free to times 2 by 180 and divide it by 5. Now, what if we just see a funny looking number like 1.57? Well, we don't see a degree, so we know it's a radian, and we need to multiply by 180 divided by pi. And if we do that on the calculator, 1.57 times 180 divided by pi, or 3.14, is exactly 90 degrees. That 1.57 number should ring a bell. That's half of pi, and we know pi is 180, therefore half of that should be 90. Again, a nice regular number like 3. Multiply that by 180 divided by pi, and get either 540 over pi, a valid answer, or its decimal, 171.89 degrees. So remember, going back and forth between radians and degrees, multiplying by the conversion factor, pi equals 180. If we have degrees on the top, we need degrees on the bottom to cancel. If we want to convert from radians to degrees, we have to go in the opposite direction. Again, we're going to be bringing you slowly into radians, slowly working with degrees, and then kind of implementing radians, possibly converting back through degrees to work on the problem, but eventually it should be all radians unless specifically asked for degrees. Okay, so sometimes when we're working on note pages, because it will be easier for me to just draw on the actual note page itself, sometimes I'm going to do that. So in the top left, we're going to count by pi over 6. Pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, which we know is pi and 180, etc. 7 pi over 6, 8 pi over 6, etc. Then, if we move off to the right and we simplify those, remember we're counting in pi over 6. 180 divided by 6 is 30, so we're counting in 30 degrees. But when radians simplify, they look very odd. So if I count by 30, it's really simple. 30, 60, 90, 150, 120, 180, 210, etc. And when I count by pi over 6 with a denominator of 6, it's really simple. Pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, etc. But if I simplify all those fractions off to the right, I get pi over 6, pi over 3, pi over 2, 2 pi over 3, 5 pi over 6, pi, 7 pi over 6, 4 pi over 3, etc., which doesn't count very well. So again, we're going to be going back and forth between radians and degrees wherever necessary. So pi divided in the next set of row in the notes. Pi divided by 3, 180 divided by 3 is 60. Counting by 60s would be simple, 60, 120, 180, etc. But we're going to count by pi over 3. Pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, 6 pi over 3, 7 pi over 3, 8 pi over 3, 9 pi over 3, 10 pi over 3, 10 pi over 3, etc. 8 pi over, yeah, okay. So we can keep going, notice. Now let's count in pi's. So pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, etc. Pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, etc. Simplify those. 0, pi over 4, pi over 2, 3 pi over 4, 4 pi over 4, 5 pi over 4, 3 pi over 2, 7 pi over 4, 8 pi over 4, 9 pi over 4, 10 pi over 4, etc. So again, being very comfortable counting in radian measure. Please practice just like you've counted by 2s. 2, 4, 6, 8, 10. Pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, etc.